Hi guys, so this week we're going to talk about least common multiples, also known as LCM. Least common multiples are multiples that are shared by two or more numbers, and we sometimes call them common multiples. So how I want you to think about this is if you draw a Venn diagram, I'll do two different colors here. Alright, so let's focus on the red being prime factors of 8. And then we'll talk about the blue being prime factors of 12. Okay, so going through our list here, and if we are going to remember that we're talking about prime numbers, so numbers that are only evenly divisible by themselves, and 1. So starting first with 12, so for this one, we would end up with 3, and then listing out 8 would give us 2, and then together they would have 2 and 2. Okay, so how I was able to get that is if we look at, remember this is our 12 and this is our 8. So the blue gave us 3 times 2 times 2. 3 times 2 is 6, times 2 equals 12. Whereas over here with the 8, we got 2 times 2 times 2, which equals 8. Okay, so they have the shared 2's there. So together, to list the LCM, you actually take all those values, 3 times 2 times 2 times 2. Okay, so these came from the middle of the Venn diagram, and the 3 and the 2 were from the outside. So together we have 3 times 2 is 6, times 2 is 12, times 2 is 24. So that would be our LCM. Okay, so just remember here that LCM is our least common multiple. Just remember that those are the same things. Okay, we'll go back to our blue here. So you can find the LCM of two or more numbers by listing multiples. Oh, sorry. Or by using prime factors. Okay, so let's start out by using multiples. Okay, so we're going to start by looking at finding the LCM of 4 and 6. So we're going to list the multiples of each numbers. So starting with the multiples of 4. So those would be 4, 8, 12, 16, 20, 24, 28, 32, and 36. We'll just stop there because remember we're looking for the least, so we don't really need to go on forever. And then we'll look at the multiples of 6. And we have 6, 12, 18, 24, 30, 36. Okay, so some common multiples of 4 and 6 would be 12, 24, and 36. So the least of these common multiples is 12. So we would say the LCM is 12. Okay, so that's just using lists of multiples. So now we're going to look at the prime factorizations, which I prefer a little bit better, but it's really up to you. So, sorry, back to my blue. Okay, so what we're going to do is we are going to make a factor tree for each number. Okay, so we're going to do, the example is 16 and 20. So I'm going to start with 16. Make sure I have enough room here. So 16, maybe. There we go. We have 2 times 8. So remember, prime factorization we looked at a couple lessons ago. So then we'll break 8 down to be 2 times 4. And we'll break 4 down to be 2 times 2. Okay, let's go over to do 20. I'll do that one in red. So 20, 2 times 10. 10 becomes 2 times 5. And we're stuck there. That's it. Okay, so from here, we're going to write the prime factorization of each number. So circle each different factor where it appears after we're done writing this, okay? So starting out, let's do 2 times 2 times 2 times 2, okay? So 16 equals 2 times 2 times 2 times 2. And then for 20 equals 2 times 2 times 5. Okay, so from here, this is where we're going to circle each different factor where it appears the greater number of times. Okay, so with 16, it appears 4 times. So we want to circle these. Okay, and then jumping over to 20, we already dealt with the 2s, so we don't need to circle those. So now we're just looking at the 5. Okay, so the 2 appeared more often with the 16, so we circle all those 2s. Now the 5 appears once, so don't circle the 2s again. Now we want to find the product of the circled factors. So I have 2 times 2 times 2 times 2. Those came from over here. And then I have my times 5. Okay, so together this comes out to equal 80. So our LCM is equal to 80. Okay, so that's using your prime factorization. So if you look at this and visualize it with the Venn diagram, that might kind of help. Okay, because we already have these, and these two would be shared. Okay, so let me explain that again. So if I had, we'll use yellow, my Venn diagram. Okay, so this side right here would have been these 2s. Okay, the middle would have included these, which also would have included these. Okay, so those are taken care of in the middle. And then over here, in the last part, that would have been our 5. Okay, so that's looking at it visually with the Venn diagram. You don't have to do it that way. If looking at it completely with the factors tree is easier, then go for it. All right, example 3. Now we're finding the LCM of 3 numbers. Okay, so from here, there's a couple different ways that we can do it. So I'm going to go through and write the prime factorization of each number. Okay, so starting with 4, you don't have to use a factor tree. You can just do, okay, well this is my 2 times 2. Then next I'm going to do 15, which is 3 times 5. No tricks there. 18, if you need to think of it as a factor tree, that's fine. So that's 2 times 9, and 9 becomes 3 times 3. So the prime factorization is 2 times 3 times 3. Okay, so now we're kind of thinking of a triple Venn diagram in a way. So we want to go through and we're going to circle each different factor where it appears the greatest number of times. Okay, so the first thing that's in multiple values, we have the 2s. However, it appears first with 4, so those are the ones we're going to circle. Okay. So we're going to circle both of those. Next for 15, 5 appears here only, so we need to circle 5. There's a 3 there, but however with 18, there's 2 3s, so those need to be circled. Okay, we're not circling the 2 because we already counted the 2s with the 4. So for our LCM, we have 2 times 2 times 5 times 3 times 3, which just comes out to be 180. So our LCM is 180. Okay. All right, last problem, looking at an application problem. These are always good. So here we're looking at a traffic light that changes every 30 seconds. Another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? Okay, so all this is asking us to do is look at multiples. So let's start out by looking at the multiples of 30. Okay, so we have, to start with a few, 30, 60, 90, 120, and so on. Next we'll look at multiples of 40. So here we have 40, 80, 120, 160, and so on. So we want to now circle the least common multiple. So looking at our list, we should all recognize that we see 120 and 120. So if the LCM is 120, That means that both lights will change again after 120 seconds. Now, just be careful in these problems, however it asks. So in this case, it says after how many minutes. If it had said how many seconds, then we would be good. But it didn't say seconds. It wants how many minutes. So we just need to convert it. So 120 seconds, remember, just equals 2 minutes, because each minute has 60 seconds. So our answer here would just be 2 minutes. Okay, so there you go. So there is your week 5 video. Just remember that if you're just catching up now, you have weeks 1 through 4 that you can go through and complete by the end of July. Always try and watch the videos first. And if you have any questions, you have your Google Meet as an option. You can always email or message any of your teachers and we can be there to help you. Along with this video, there will be a couple other short Khan Academy videos uploaded as well. Those are just optional, just in case you're confused on the material. All right, have a good week and a happy 4th of July.